Kinematics of DT26 HP machine gives us information necessary to prepare a program. We can find out there about machine capacity, about axis names, their layout and strokes, as well as about all available drives, their names and maximum rotation speeds. The separate extensive issue are holders and tools, their layout, and geometries. This is the photo of our machine. You see configuration selected for machining of our sample part, but of course many other configurations are also possible. Our machine is like 2-in-1 because we have 2 spindles and 2 channels connected with them. Channel 1 involves main spindle and all tools assembled on gang 1. Channel 2 consists of back spindle and tools mounted on this gang 5. In both spindles we can machine material of maximum 1 inch diameter, it is 25.4. We often will use as synonym for channel 1 main operation, and by analogy back operation as synonym to channel 2. Our machine has 5 axes. 3 of them with index 1 are prescribed to channel 1. The first of them, vertical X1 axis, is directed in minus to the material. It means that in this direction goes the whole gang when we would like to approach to the material. To go up in plus direction, this is retraction. Axis Y1 we use when positioning a tool for machining or also, for instance, in milling operations. The third axis, Z1, represents movement of a bar. In channel 2, we have 2 axes with indexes 4, X4 and Z4. Back spindle moves in these axes. Tools don't move. Please look into minus direction in both Z1 and Z4 axes. Movement in minus direction in Z1 means withdrawing a bar in the machining area. In plus, this is retracting back. In Z4, direction in minus means approaching to a tool. This means that in a program we will use negative values in this operation when we would like to position in material. Also, it is necessary to add that both x-axes, x1 and x4, are by diameter. Positions in these axes are given by diameter. The resolution in axis of our machine is 0.1 micrometer. It means that when entering positions in a program, we can give 4 digits after decimal point when we would like to enter a value in millimeter. The same it concerns displaying of positions on a machine. In this picture, you see all available drives on our machine. First, we have main spindle, denoted as S1, and back spindle, identified as S4. We have in both channels rotating tools. In channel 1, for them, there is one drive. You see it is S11. The maximum rotation speed for this drive is 6,000 RPM. In back operation, there is also one drive, identified as S51, and in program we can enter this rotation not bigger than 7,200 RPM. Both spindles have maximum rotation of 10 3000 RPM. And as you see, for both spindles, C-axes are available. We can mount on our machine holders for stationary tools as well as for rotating tools. All of them are assembled on a machine on pins, as you see, and fixed by screws. The layout of those pins and dimensions are shown in the kinematic drawings. Those kinematic drawings you can find in Tornos documentations. The first one is Tornos manual for our machine titled Use, and the second one is programming manuals. Please pay attention that this is programming manual for Code G System C, which we use to prepare a program. In these two drawings, all pins to assemble holders are shown. You can notice here that they are described as PF, it means fixation point, and all of the fixation points are numbered. One of them, the 13th fixation point, is the specific one. But as you see, there are the other specific points of a machine shown in the drawings. First, this is machine 0, like this shown here and here, and also reference points in subsequent axes. The reference point in X1 axis is determined according to PP. We also can call it control point, this specific pin. When the distance between machine 0 and control point position is by diameter 316, this is the reference position in axis X1. In axis Y1, we also determine reference according to control point. Please look, if we move that whole gang to the right, and the distance between machine 0 and control point would be 89, then it is the reference point in axis Y1. The value is negative because there was movement of a gang in the minus direction of axis Y1. The second drawing to the right shows us reference position first in Z1 axis. Generally, we can say that reference in Z1 is forward position of main spindle, but the exact value depends on the configuration. When we work with guide bush, then this is in point 120. When we work without guide bush, this reference point of Z1 is much more forward and equals minus 18. Surely you've noticed that there is also the third reference point of axis Z1. It is in position plus 345. This reference is special, dedicated for service, and that is why we will not focus on it. So let's continue with channel 2. In channel 2 and axis Z4, we have reference position at the value 303. This is retracted position of back spindle. In axis X4, the reference is in 0. It means that back spindle is positioned in front of main spindle, and then centers of both spindles are in the same line. And these two drawings show us the maximal and minimal positions in each axis. The difference between maximal and minimal position is called stroke, and it is distance. It means that it is defined by radius, not by diameter. Let us look into the range of movement of axis x1. It is determined according to control point. This control point cannot reach the machine zero position. The smallest value is 104. But this position corresponds with position of a tip of a standard tool 1 millimeter below the center of a bar. Here you see the stroke for axis y1, and moving to our drawing to the right, you see the strokes for axis z1. First, it is necessary to emphasize that the value of stroke depends also on the configuration of our machine. When we work with guide bush, then we have longer stroke, and this is 225. In the case of work without guide bush, the stroke is much smaller and equals 55. So you know that the mode of working of a machine without guide bush is dedicated to short parts. In channel 2, the range of movement is described here, and stroke equals 270 millimeter. This lower value, 32.5, corresponds with use in channel 1 standard stationary cutting tools with cross section of 12 by 12 millimeter. And the last axis, x4, then there is the range of movement, which gives us the stroke of 329. This stroke is enough first to make pick-off and also to position back spindle in front of a box collecting of part to execute ejection of a part.